Let's start with a scenario where all the devices are online. This represents a normal situation with first responders. Through the demo, we'll see how our application can evolve with the environment to support different use case scenarios. Here, we have Bob firefighter, Charlie commander in a group conversation. For demo purposes, we visualize the audio input and output at the bottom of each device. In our new application, we do not mandate that the communication parties be in a synchronous call before they can talk to each other. However, when they're both in the same conversation like Bob and Charlie are, they can just push and talk, like before.
Have you heard that next-gen MCPTT is upgrading their platform? Yes, they are trying to support PTT with D2D capabilities.
You can see that the voices are delivered in about real time so that Bob and Charlie can feel that they're still using the traditional PTT application. Since we do not mandate that the users communicate synchronously in a group call, Alice, firefighter, can communicate with David to deal with some emergency matters while Bob and Charlie continue to talk to the group. Our application stores the messages and gives an indication to Alice saying that she has unread messages in other conversations. When she finishes the discussion with David, she can switch to other conversations. Here, we show all the conversations Alice has. At the end of each conversation name, we put an icon to indicate the number of unread messages. The conversations are ordered based on the time of last message so that the most recent conversations are always listed on the top. Alice can also pin some important conversations on the top. For example, she now has David pinned. Let's unpin David and pin Ed instead. Now Alice decides to join the call with Bob and Charlie. The messages she has missed will be played automatically one after another. She can join the conversation without missing any information.
Have you heard that next-gen MCPTT is upgrading their platform? Yes, they are trying to support PTT with D2D capabilities.
I believe the D2D capabilities will help us a lot.
Alice can also replay the message by clicking the message body just like before. We skip this step here. When designing the conversations, we allow emergency messages that are sent to the members of a group to interrupt the current conversation so that we can ensure the delivery of the important information. To send an emergency message in a conversation, the sender needs to click the alarm button at bottom right. The emergency PTT button would pop up. This two-stage design was recommended by the first responders to prevent mispressing of the emergency button. Let's assume that now Alice is in another conversation and Bob is playing a normal message. Let's see how our application ensures the emergency message gets the attention from both of them.
Everyone, evacuate immediately.
We can see that on Bob's side, the playout of the normal message is interrupted and the application plays the emergency message first. Alice would receive an alert since she is not in the conversation. The alert would tell her the conversation that she has received the emergency message. By clicking the View button, she can navigate to the conversation immediately. While the conversational view helps first responders focus on the communication in a context, we also notice that when a first responder, say for example a commander or dispatcher, who has to deal with multiple conversations, switching back and forth among them would be time-consuming and distracting. In the new design, we allow first responders to create combined conversations to have an integrated view. For example, here, Charlie is managing an incident, Ridgecrest. Alice and Bob are in two different groups since they are working on different tasks. It would be undesirable to put the users into the same group since the excessive amount of information would confuse and distract the first responders. So Charlie creates a combined conversation with the two groups in it.
Alice reporting from the search team.
Bob reporting from the firefighting team.
We can see that all the messages exchanged in the group are shown in the integrated view. To distinguish the messages going to different conversations, we show the sender and receiver or receiver group on top of each message. Charlie can also choose to reply to a group by selecting the group name and then push to talk.
Search team, extend your search to the tree line in the west area. Firefighting team, watch for any open flames from the buildings.
Now, let's assume that Alice is in an environment with intermittent connectivity. This is our connection management page. We'll talk about the functionalities on this page later. For now, we see that Alice is currently connected to our server. For demo purposes, we now manually disconnect Alice from the server. We now let Charlie send a message.
Please let me know your current location and your ETA.
We can see that Alice cannot receive it since she is not connected. However, the message is buffered on our server and waits to be delivered when Alice gets back online. Now let's connect Alice back to the server.
Please let me know your current location and your ETA.
You can see that the message is played immediately when the connection is established. Similarly, we also allow the sender to be offline when sending a message. Let's assume that Alice is offline again. Now Alice replies with a message.
I'm in East Village. My ETA is 10 minutes.
We can see that our application cannot send a message out since Alice is offline, but the application stores the pending message. Later, let's assume that Alice comes back online since she has just moved to an area with internet connectivity.
I'm in East Village. My ETA is 10 minutes.
We realize that since the messages from Alice was not delivered immediately, it is difficult for Charlie to determine the real ETA of Alice in this scenario, because of the transmission time may be different from when she spoke. To address this, we also indicate the time each message is recorded in the message header. Based on this information, Charlie can easily determine the ETA of Alice. Now, let's assume that Alice goes to a harsher environment where she does not have internet connection at all. However, she has a nearby colleague, Bob, who happens to have internet connectivity via LTE or a carefully managed satellite connection. In this case, Alice can request Bob to forward the messages back and forth. The channel between Alice and Bob can be established using Wi-Fi Direct, Bluetooth, or even a local area network. Here, we first use local area network as an example. Now the application on Bob has seen that it is responsible for Alice. It would also notify the server that the messages to Alice would be sent to Bob instead.
The situation has stabilized. I don't have an internet connection, but Bob's doing forwarding for me.
Great. Please give me another report in an hour.
We see that users can communicate just as if Alice is connected directly to the server. Similarly, we also support Bluetooth connections.
I'm now connecting using Bluetooth.
Acknowledged.
This technique is not unlike the tethering functions provided by many smartphones, but in a more efficient way. When Charlie wants to send a message to both Alice and Bob, only one copy of the message will be transmitted, and Bob will take care of the replication. This would be useful when the channel has limited capacity, for example with satellite connections. Since we do not have the strict requirement for synchronous calls in the system, Bob can forward multiple conversations for multiple users at the same time. For example, Bob can forward messages for David, who is talking to Ed, and at the same time forward messages for Alice, who is talking to both Charlie and himself. We have muted the concurrent conversations, but you can see the audio input and output on the GUI. We have support for both group and private conversations, no matter whether the forwarder is in the conversation or not. We also allow multi-hop forwarding to extend the range of internet connection. Let's assume that David can only reach Alice now, rather than reaching Bob directly. Bob will see that he is forwarding for both Alice and David, but via Alice. Now David wants to speak to Ed. Both Alice and Bob will forward the message for him.
I'm a bit far away now, and I am using multi-hop forwarding. Good. Please search the area carefully.
In this last scenario, we assume that even Bob has lost a connection to the server, but the 3 first responders in the field still need to communicate with each other. In this case, a first responder can volunteer to act as a local temporary server to aid in the message dissemination. Now, we let Bob be the local server. Now the server has started. The server would borrow the information from Bob's application and know the user and the group relationships. Based on this information, the first responders can communicate with each other as if they are still connected to the internet.
It appears that we have lost internet connectivity, but we can still communicate. I think Charlie might arrive in an hour.
Our local server also has the built-in delay-tolerant feature. When the message is not successfully delivered, it will store the messages until its successful delivery. For example, when Charlie reaches the search field and connects to Bob, he will receive the messages he has missed so far.
It appears that we have lost internet connectivity, but we can still communicate.
Likewise, if Charlie has some pending messages, those messages can be delivered via Bob to the first responders in the field also. Now, all the members in the field can communicate locally.
Please meet me at 4 p.m.